Good morning, class. Again, it's Mr. Kablan here, and today I'm going to present to you the third lesson in Chapter 2, which deals with trends, interpolation, and extrapolation. So just to do a quick recap of what we did in yesterday's lesson, or should I say the last lesson, I introduced you in how to create what are called scatterplots, which is simply plotting a bunch of ordered pairs on a Cartesian plane, and then from there, drawing conclusions based on analyzing it, as well as determining which direction the points were going. Now, I kept mentioning the word trend and pattern yesterday, so today I will formalize that definition when it comes to trends, interpolation, and extrapolation. So those three words I'm going to introduce to you based on definition, and then we're going to take a look at several examples on how we can apply that on graphs and other sets of data. So as we proceed over here, take a look at what we have here. Again, the topic for today is trends, interpolation, and extrapolation. So the first thing what we're going to look at is the fact that we need to formally define what those three things are. So first of all, in the last lesson, I kept mentioning the word pattern and trend, and simply what this is the overall direction of where the points are going. And there are two general types of trends, and the first one here is an upward trend. So if you take a look at this graph over here, okay, notice all the points are going upwards. Okay, so that's an example of an upward trend. Okay, the opposite of that is a downward trend. And again, if you take a look at the majority of the points, it's as you go from left to right, notice that all the points here are falling down to the right. So these are the two general types of trends that we'll be seeing in this particular chapter. We're also going to take a look at another type of relationship in a future lesson, but these are the two that we're going to focus on in today's lesson. Now, the first type of prediction is what's called interpolation, or for us to interpolate. Now, the definition of interpolation, or what it means to interpolate, is to come up with a guess of a value based on the data that's given to you, and you're basically looking inside the data. So if you take a look at the two graphs that you see on the screen over here, the way I'm going to display interpolation is using a line which estimates what the values will be. So notice if I read on the x-axis over here and I want to figure out or guess what the value is on the y-axis, okay, I would just have to read off this red line that you see that I've drawn over here. So when I read off the x-axis, the corresponding y value, that would be the guess for that particular scenario there. Okay, and just to let you know, interpolation works in both directions. So if I want to figure out a value for x, okay, I can just interpolate just like I would by reading off the y, okay, and then seeing where it falls on the x. So interpolation works in both directions. Now, just how it applies to the other graph over here, again, interpolation, again, is a guess inside a set of data. So when you're given a set of data, okay, these red lines just correspond to how you could figure out or make a guess based on the data that is given to you. So you're basically making a guess on something that is not provided for you on a table, okay, and you're just estimating based on the values that are, okay, so that's interpolation. Right, so the opposite of that is what's called extrapolation, or to extrapolate. Now, all this means is that you're now making a prediction outside of the data that is given to you. Now, what it means to make a prediction outside of the data is that means you're looking at the values that are beyond the points, as well if there are any, if it starts off a little bit further up over here, you can also make a guess on the points before. Okay, so that's what it means to extrapolate. So an example for this one over here on the top right-hand corner, notice with this blue line over here, okay, I am now reading beyond the data that's given to us over here. Okay, so we're gonna see an example of that in the next example here, just to give you a better understanding of how extrapolation works. Okay, same thing with the downward trend. If you take a look at this over here, okay, you notice I've made an estimate based on information that's provided for us beyond the data that's given. So for both of these graphs, if you're looking at at each ordered pair on the Cartesian plane, okay, you can see that each one there, these are the given pieces of data on a table of values, and the ones that I have drawn here, in this case, the blue line, are the predictions beyond that set of data. All right, so let's take a look at examples so we have a better understanding of how extrapolation and interpolation works. So what we have in this first example is we're going to use a trend to make a prediction based on temperature. So it says here, below is a chart with temperatures recorded over a 10-day period in March. Now, before we graph this over here, the first thing we need to do is determine which one goes on the horizontal axis and which one goes on the vertical axis. Now, remember, on the horizontal axis, okay, the values for the independent variable or the variable that's in control, that's what we would label on the horizontal axis. Now, in the previous lesson, I mentioned that if you're given a table that looks something like this, okay, where everything's broken up according to row and column, 99.9% of the time, the top row, that would be the independent variable. So in this case here, the day would go on the horizontal axis. All right, so that would make the bottom values go on the vertical axis. Okay, and the vertical axis in this case here would be the temperatures based on what you see below. Now, just looking at these numbers over here, just to also, before we actually graph this, notice the days are in order. Okay, that tells us that we are recording this in this order over here. And the numbers right below it will be the corresponding values for the temperature on that given day. And just to clarify again, going back to what we did in the lesson when we were looking at independent variable and dependent variable, okay, if you look at the increments or how much each one is going up by, notice that each one here is going up by 1. Okay, if there's some sort of a pattern in especially in a certain set of values, okay, that helps in some circumstances, but for this case, for the time being, we're just going to focus on the fact that the top row will be the independent variable, which will be going on the horizontal axis. All right, let's graph this. So if you take a look at the graph over here, okay, just again, we've labeled the x going from left to right over here, which tells us this represents the number of days. Okay, so let's label that accordingly. Okay, and the vertical axis, that'll be the minimum temperature. And I think that gave it away based on the graph that we had negative values going downwards and positive values going up. Now, each of these numbers that you see, okay, will represent what we learned as an ordered pair over here. So starting off with this first one, we have 1 and -9. So the way we do that is from the center, okay, we're going to go down right 1 and then down 9. Okay, so there's our first point. So 2, -6 tells us that we're going to go right 2 and then down 6. All right. Next one will be 3 and -3. So we're going to go right 3, down 3. Okay. Next one is right 4, down 5. Okay. Next one here is 5 and then down 4. Next one here is 6 and down 1. Okay. So notice that we are going to the right for all of them for the days here. Okay. And just to finish this off, we have 7 and 0. Okay, 8 and -1, 9 and 2, and last but definitely not least over here, this will be 10 and 3. Okay, now notice that we've only plotted 10 points over here. So what we want to do here is just to look at the overall picture to see what it's trying to tell us based on this, what we have in this chart, in this table of values over here, as well as the graph. Okay, so let's answer a couple questions. All right, so it says here, describe any trends in the data. Now remember, the way to describe the trend is the basic or overall direction of the data that you have plotted on this graph over here. So as we read these, always read it from left to right. So as we go from left to right over here, okay, starting with this bottom left point, notice the general direction or general pattern is upwards. Okay, and since all of them are going upwards, okay, or most of them are going upwards, should I say, okay, this is an example of an upward trend. Now you notice that it's not steadily going upwards because it is temperature. Okay, temperature changes quite frequently. So I want you to see we're looking at the overall general trend. Okay, so that's why it's upward. All right, so the next question, it says use extrapolation to predict the temperature on day 12. Now, just to recap the definition of extrapolation or what it means to extrapolate, okay, we are now reading beyond the data that is given. So let me clarify that. So if you take a look at the number of days, we've only plotted the temperature from day 1 all the way to day 10. What we're doing here is now making a prediction or an educated guess based on a day that's beyond day 10. So we are looking at day 12. Now, the way we're going to do that, again, is we're just going to take a look at the overall trend and see where we think the 12th day might lie when it comes to temperature. Now, we are going to assume that's going to follow the overall trend. So as you go up here, again, we're just going to make a guess. Okay, we're going to think and guess that on the 12th day, the temperature will be right there. Now, again, this is not exact because as you can see, this is a scatter plot. Okay, and as you know, weather is pretty unpredictable. That's why when you explain your answer, okay, you have to say the temperature on day 12 will be around or approximately 4 degrees Celsius. So if you take a look at day 12, okay, and you look across over here, you notice it corresponds to day 4. Okay, so actually I'm just going to draw a line there to just make things a little bit clearer over there. All right, so here's day 12. Okay, and again, we made a prediction based on the trend. So if you look at day 12, okay, and you look across like this, you notice it hits approximately day 4 there. Okay, so that's why I want you to see that when you're making a prediction, okay, you're just reading basically off the graph. Okay, all right, so let's take a look at another example, and this one here is slightly different because the graph, so just to go back to this one, okay, notice the graph here, we're using points. This next graph is going to be slightly different because we're going to be looking at bars. So the same thing, we're going to approach it the exact same way using trends, okay, but with a slightly different type of graph here. So it says here, the table shows the number of paid admissions to movies in Canada for 12 months ending on March 31st. The graph represents the data in the table. Now, as you can see, not only do we have a table with the numbers, but we also have a graph that has already been provided for us. Now, just to go back to the independent and dependent variable, because it's already done for us, okay, notice the top numbers, which represent the years. Okay, notice that these are going on the horizontal axis. That's just like we did in the last example. Okay, and if you take a look at the bottom row over here, in this case here, it's the attendance in millions that goes on the vertical axis there, okay? Now, what I want you to see here is that we are now using a bar graph over here, okay? And if you check, we started up from 1994, okay, and it ended in 2003. Now, if you take a look at the dead center over here, notice that this is the question that we want to ask here based on the data that is given. That's why if you take a look at the question over here, when we take a look at question B, okay, we're going to revisit this definition over here, the interpolation, all right? So it says describe any trends in the data. Again, just like the previous question over here, okay, if you take a look at the general pattern as we go from 1994 to 1993, or from left to right in every case, okay, in overall, okay, the general pattern is upwards. Now, notice I was very picky when it comes to the wording here. It says there's generally an upward trend. And the reason why I say it's generally, because you notice in 2002, it kind of reaches a peak and then it goes back down. However, for the majority of the graph, you notice that what we're having here, okay, is that the graph is going up, okay? Now, for question B, it says use interpolation to make a prediction for the attendance in 2001. Now, remember interpolation, you're now making a prediction, okay, within a given set of data. So since we have values from 1994 for 2003, we're finding something that is missing in between those set of data. And the best way to do this, again, this is just a prediction, is I'm just going to draw a bar that looks like that. Okay, so how do we know where the bar is, or how do we make a bar that's accurate? Well, we know that it's an overall upwards trend. Okay, so the bar over here will be anywhere in between 120 to 125. That's why if you take a look at my final answer here, I said the attendance in 2001 was approximately 123 million. Now, is that the exact value? Okay, probably not, but based on the overall pattern, okay, it's a really, really good estimate in terms of what the value will be based on the overall upward trend. All right. Okay, so that wraps up today's lesson, and I'll see you on the next one. Good day.